You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer the question of the special coordinates for our arc pi over 3, let us have this unit circle here. This again identified as a unit circle because the distance of a point on the circle from the center is just equal to 1. So even if you have a point here, okay, if we're going to draw a line connecting that, it's just equal to 1 because they are both radii of the same circle, and all radii of the same circle have the same measurement or are congruent. Okay. But this time, we are going to look into the reason behind the special coordinates of the terminal point of the arc pi over 3. Now, this is one of the special arcs which you were able to memorize, or it's easy to memorize this, but it's also important for you to understand the reason behind the origin of that point so that you will be able to analyze as well the importance of other concepts in mathematics related to the unit circle. First, let's try to come up with the equivalent of pi over 3 into an equivalent degree measure, because we need to use the degree measurement because we could have later a special triangle, in this case our triangle, that we can use in understanding the special coordinates of the terminal point of pi over 3. We can actually convert pi over 3 into degree measurement by multiplying with this ratio or this conversion factor. We have 180 degrees over pi. This is the process of converting a radian measure, because pi over 3 is a radian measure, into an equivalent degree measure, because once you do that, you could cancel here your pi, and 180 divided by 3 is equal to 60 with the degree unit of measurement degrees. That would mean pi over 3 is equivalent to 60 degrees. If we're going to look back at this unit circle, we know that this is 90 since this is perpendicular here, the two axes are perpendicular. That would mean our point for a terminal point for our 60 degrees is somewhere here, just like that, or the other way around, from the center here. If my drawing is accurate, this would be the terminal point of our pi over 6. That would mean this is this arc here. That's your pi over 3. This is your pi over 3, or equivalent to 60 degrees. Okay? Now, if we are going to look at this relationship and draw a vertical line from that terminal point towards the x-axis, we have here, and make sure, by the way, making sure that the line is perpendicular, we have here a 90 degree. Hence, we could come up with a 90-degree triangle we know as right triangle. We are looking for the coordinates or the special coordinates of the terminal point of pi over 3, which is represented by x and y. And what does this x and y represent? This x, let's start with x, is the x value of this, meaning this is the distance from the center until here. This is x, okay? And y corresponds to the height of that point. This would be our y, the height. Okay, so we have x here and y, and we know this to be one of the radius, or a die. This is equal to 1, and that's our hypotenuse here. So we're going to look that here and zoom in. I'll probably draw a larger version of that. Hopefully my drawing is accurate, but if it's not, pardon. Okay, let's just assume that this graph or drawing here is closer to what is correct. This is 90 degrees. This, again, what we're looking for, the x and y. Okay, in short, we're going to solve for x and y to get the coordinates of a terminal point of pi over 3 or 60 degrees. And 60 degrees is somewhere here. This is the central angle intercepting this arc. And this arc is pi over 3, or in degree measurement is 60 degrees. We know that the measurement of a central angle is just equal to its intercepted arc. This is also 60 degrees, which means this one, as that, is 60 degrees. This is the radius 1, this was the height y, and this is our x here. Of course, this here would be equal to the remaining angle of 30 degrees, because we know that the sum of the interior angles of any triangle, according to the triangle angle sum theorem, is 180 degrees. We have 60, we have 30, we have 90, that's 180 degrees already. Now from here, we have a 30 degrees, 60 degrees, and 90 degree right triangle. In our previous discussions in geometry, we know that this is a special right triangle because there is a relationship now from the shorter leg. The shorter leg is opposite 30 degrees. This is a shorter leg. There is a relationship from the shorter leg to our hypotenuse, and the shorter leg to our longer leg, which is opposite 60 degrees. So we'll be solving x and y in this manner. Let's start with the relationship of the shorter leg represented by x to the hypotenuse, which is 1. For 30, 60, 90 degree right triangle, from our shorter leg to solve for our hypotenuse, we simply multiply it by 2. So if this is 10, that would be 20. That's the relationship of the shorter leg and the hypotenuse of a 30, 60, 90 right triangle. Of course, going back, because it's already 1, going back here, the opposite of times 2, we are going to divide this by 2. This would mean x here can be solved as 1/2 or half of 1, or in short, just automatically, that's 1/2. The measurement of x, or the distance from the center to this point here, represented by the point which is intersecting the vertical line here, which corresponds to the x value of our terminal point, x is just equal to 1/2. So we are done with the first. How about y? Similar thing, there is a good relationship between the shorter leg and the longer leg of a 30, 60, 90 right triangle. From the shorter leg to the longer leg, we simply multiply it by square root of 3. Therefore, to solve for y is just equal to x times square root of 3. And we know x to be already 1/2, so that's 1/2 times square root of 3. When we simplify this, we can write over 1 here and multiply correspondingly. 1 times square root of 3, square root of 3, 2 times 1, 2. This is the value of y, or the height of this right triangle, which corresponds to the second entry on our terminal point. With these two values, we can now say that the coordinate of pi over 3. Okay, again, we can memorize this, and probably some of you already memorized this one, but this is the reason behind. It's a combination of x and y. Our x here is 1/2, and our y is square root of 3 over 2. Now it's fine. It's already a good time for you to memorize, as long as you're able to understand how was this came into being. And it took a lot of effort in proving or showing the coordinate of the terminal point for a pi over 3 arc or 60 degrees. Thank you for watching.